Now, a new study suggests that the moon may have a similar tail, but it's only visible once a month.
Scientists have known that the moon has a tail, like a comet, since the late 1990s.
Even with all of today's wonderful technologies, the universe is a complex and largely unknown realm. Science continues to fight, despite having many more questions than answers, to comprehend more about the existence of everything in the universe. And despite the fact that the moon is quite close to our planet and has been visited by both spacecraft and humans, there is still so much we don't know about our nearest neighbour. The scariest aspect is that any disaster that occurs on the moon will surely harm us. The problem is that our moon is behaving strangely. Flare-ups, fire eruptions, and rainbow fog. It begs the question, is this celestial body all right? Astronomers are still unsure what all of these odd moon symptoms mean. Today, in this video, we will look at weird occurrences occurring on the moon that will astound you. If you stare at the moon for long enough, you will begin to see things. 82 things to be exact, says Bill Cook, NASA's Meteoroid Environment Group leader. That is how many transient phenomena the group has videotaped since they began studying the moon's night side. Transient lunar phenomena, TLPs, are defined as brief fluctuations in the brightness of regions on the moon's surface. They can endure from a few seconds to a few hours and expand from a few kilometers to 100 kilometers in size. Most TLPs are described as increases in the overall luminosity of a moon spot. But occasionally observers record a fall in brightness or even a shift in colour to red or violet. The TLPs have been described as mists, clouds and volcanoes, among other provocative terms. Even today they remain poorly understood. Short-lived lunar events have been claimed for at least 1,000 years, with some being observed independently by many witnesses or respectable experts. Nonetheless, the bulk of reports of transient lunar phenomena are irreproducible and lack proper control tests that may be used to discern between competing ideas to explain their origins. Most lunar scientists agree that transitory processes like outgassing and impact cratering occur across geologic time. The point of contention is the frequency of such occurrences. It has been proposed that effects related to electrical charging or discharging could explain some of the fleeting lunar occurrences. One hypothesis is that electrodynamic processes caused by near-surface material fracturing could charge any gases present, such as implanted solar wind or radiogenic daughter products. If this happens at the surface, the subsequent ejection of this gas may be able to cause phenomena visible from Earth. Alternatively, triboelectric charging of particles within a gas-borne dust cloud has been postulated to cause electrostatic discharges visible from Earth. Finally, electrostatic levitation of dust near the terminator could result in an observable phenomenon from Earth. The most serious issue with reports of fleeting lunar occurrences is that the vast majority of them were made by a single observer or from a single location on Earth, or both. A plethora of reports of transient phenomena occurring at the same location on the moon might be used to support their existence. However, in the absence of several eyewitness claims from multiple locations on Earth for the same incident, these must be treated with care. Are you aware that the moon has a comet-like tail? It sends a beam around the Earth once a month. Carl Sagan once remarked that the Earth is little more than a mote of dust suspended in a sunbeam. He'd undoubtedly be overjoyed to learn that during a new moon, Earth is a mote of dust suspended in a moon tail. The moon is continually attacked because it lacks an atmosphere to protect it. Sodium atoms fly high into orbit when meteorites strike its volcanic surface. Photons from the sun collide with sodium atoms, forcing them away from the sun and forming a tail-like structure running downstream from the moon. It makes the moon sort of like a comet, said Jeffrey Baumgardner, a senior research scientist at Boston University's Center for Space Physics. It has a stream of stuff coming off it. When the new moon passes between Earth and the Sun for a few days each month, this comet-like tail dusts the side of our planet that faces the Sun. the gravity of our planet pinches the sodium stream, narrowing it into a beam that wraps around Earth's atmosphere and shoots out into space from the opposite side of the globe. Special cameras can detect this moonbeam as a point in the twilight skies. It appears brighter at times and darker at others. Since the tail and its beam were first observed in the late 1990s, scientists have been wondering what governs the brightness of the beam. 14 years of data imply that meteors, particularly larger, quicker ones that attack the moon at random, may explain what governs its flicker, according to a study published Wednesday in the Journal of Geophysical Research, Planets. Does this have a practical application? Probably not, said Mr. Baumgartner, the study's lead author. He claimed that his investigation was motivated solely by curiosity, a desire to learn more about the gorgeous volcanic pearl in the sky and its mysterious moonbeam. I think it's very cool, said Sarah Lutgen, an undergraduate at Boston University and an author of the study. It almost seems like a magical thing. Boston University has deployed many all-sky imaging cameras around the world, which are effectively fisheye lenses that see the entire visible sky. They were originally designated to detect auroras, but with a filter they can see sodium in the Earth's atmosphere. They frequently see it when meteors burn up before reaching the Earth's surface. During the peak of the annual Leonid meteor shower in November 1998, a team working with one of these cameras at the McDonald Observatory in Fort Davis, Texas, hoped to see these sodium flares. They were perplexed when, soon after the peak, a sodium spot lingered in the sky for 3 nights. This spot, which appeared on the opposite side of the planet from the Sun, brightened as the new moon approached, then dissipated swiftly. Following more research, including models that approximated where the sodium spot could be coming from, the researchers concluded that it was caused by a comet-like tail of sodium stretching out at least 500,000 miles from the moon. The tail may be scattering sodium all over the Earth, but it is incredibly dispersed, so no moon dust dandruff will accumulate on our heads, according to Luke Moore, a senior research scientist at Boston University and a co-author of the study. The moonspot in November 1998 was very bright after the peak of the Leonid meteor burst. It was also seen on other new moons when there were no concurrent meteor showers, but it was fainter. As a result, the scientists thought that the meteor shower hits were chipping away at enough sodium to feed a very bright spot. However, the all-sky imager camera at Argentina's El Leoncito Observatory, which captured 21,000 photographs of the moon between 2006 and 2019, paints a slightly different story. Annual meteor showers, such as the Leonids, which are among the most powerful, can coincide with a stronger moonspot. However, this isn't always the case. Maybe because their collisions aren't always powerful enough to propel lunar sodium far enough away from the moon to contribute to the comet-like tail and moonspot. Impacts from irregular meteors, which do not appear in normal showers, have a larger association with the brightness of the moonspot. This could be because they are more massive, faster, and can collide with the moon head-on, allowing them to expend more sodium into a higher orbit. If a sufficiently large asteroid collided with the moon with adequate force, it would be able to expel enough sodium to form a moonbeam visible to the naked eye, according to James O'Donoghue, a planetary scientist at the Japan Aerospace Exploration Agency who was not involved in the research. If you could see it, Mr. Baumgartner added, it would be a fuzzy patch of light about the size of the belt stars of Orion. Even though the moonbeam is undetectable, knowing that Earth has a meteor-fueled moonbeam is satisfying, a reminder of the moon's vibrancy. Furthermore, have you ever noticed a peculiar ring of light surrounding the moon and wondered what it was? The moon's halo, also known as the lunar halo, is an optical illusion in which a wide luminous ring surrounds the moon. The refraction of moonlight by ice crystals in the high atmosphere causes this startling and often beautiful halo around the moon. In effect, these suspended or falling specks of ice change the atmosphere into a huge lens, producing arcs and halos to emerge around the moon or sun depending on whether the effect occurs at night or day. The impact is so remarkable that it has given rise to a plethora of mythology and superstition. and it has been used to anticipate the beginning of terrible weather, albeit rather poorly. When light is refracted, reflected, and distributed by ice crystals floating in cirrus or cirrostratus clouds at altitudes of 20,000 feet, 6,000 meters, and higher up to 40,000 feet, 12,000 meters, a lunar halo is formed. The structure of these ice crystals concentrates light to form a halo around the moon or sun. Due to the hexagonal nature of ice crystals, lunar halos are virtually always the same size, with the moon or sun sitting 22 degrees from the other edge of the halo, roughly the width of an outstretched palm at arm's length. Because halos have a constant 22 degrees radius and 44 degree diameter, both solar and lunar halos are sometimes referred to as 22-degree halos. Because ice has a certain index of reflection and an ice crystal's hexagonal shape means that when its sides are stretched, it forms a prism with a 60-degree apex angle. This results in a minimal deviation angle of 21.84 degrees for light traveling through the ice crystal. These ice crystals also show a prism effect, which splits white light from the sun or is reflected by the moon into several different hues, similar to the atmospheric action that produces a rainbow. When light passes through a prism, different wavelengths of light and consequently different colors experience varying degrees of refraction. This means that lunar halos can be gently colored with rainbow hues on the inside and shortwave blue light on the outside. Colors in the lunar halo are frequently too faint to perceive with the human eye, but they may be considerably more noticeable surrounding the sun due to how much brighter it is than the moon. Let us know what you think of these lunar phenomena in the comments section.